So now we're going to do our derivatives and our integration examples for the inverse trig functions. All right. So this first one wants me to find the derivative of arc sine of 2x. So when you look at your formula for the arc sine, it was the arc sine of u. So u is our 2x. Okay? So when you look at the derivative of the arc sine, it's u prime divided by the square root of 1 minus u squared. So I know what u is. U is 2x. So that's going to be 1 minus 2x squared will be 4x squared. And then I just need u prime. So u prime is the derivative, so that's just going to be 2. So the answer is 2 divided by 1 minus 4x squared, or the square root of that. And that's your answer. So this is the derivative for arc sine of 2x. It's that simple. Okay, just put it in this formula is all it is. All right, so for part B, the derivative of arctan. So this is our u, the arctan of u. So the formula for the derivative of arctan, it's u prime. Remember, this was the only one that doesn't have the radical. It's 1 plus, and it's the one that's plus as well. The others were minuses. I forgot to mention that in the other video. 1 plus u squared. So I know my u is my 3x. So u prime, your derivative is 3. So when I fill this in, it's going to be 3 over 1 plus my u squared is going to be 9x squared. So there's my answer. So taking the derivatives are not hard as long as you know these formulas or are familiar with these formulas. All right. Number 2, this one says we want to do the derivative of the arc sine of the square root of x. So again, this is our u. So u is the square root of x, which we know is x to the 1/2. So then when I look at my formula for the arc sine, again, that's u prime over the square root of 1 minus u squared. So I'm going to need my derivative. So u prime is going to be 1/2 x to the negative 1/2, which if I rewrite that, that's 1 over 2 square root x. So now when I put that in here, I'm going to have u prime, which is 1 over 2 square root of x, divided by the square root of 1 minus the u quantity squared. So when you take the square root of x and you square it, that's just going to be x. Now, the only thing you can do to clean this up just a little bit is we have a complex fraction right now. So I would put a 1 under this, and then I would do outers. So outers, which is 1, over inners. So that's going to be 2 square root of x times the square root of 1 minus x. And then you can also multiply these together. So 1 over 2, you can multiply the radicals together and get the square root of x minus x squared. So it just depends on the test how far they take the simplification of that. All right. So again, I did outers over inners. I did the product of the outers divided by the product of the inners to take it from this complex fraction to this here. Okay, just to give you a little trick there. All right, and then here we haven't done an arcsecant one yet, so let's do an arcsecant one. So this says do the derivative of arcsecant of e to the 2x. So remember this is our u here. So u is e to the 2x. I know I'm going to need u prime. So the derivative of e is the same itself, and then you chain on the derivative of its exponent, which will be 2. So that's going to be 2e to the 2x. So what is the formula for the arcsecant? Well, that one was u prime divided by the absolute value of u, and then the square root of, remember, because this started with a u, it starts with a u in here, u squared minus 1. So I'm just going to plug those in. So my u prime is the 2e to the 2x, and then in my denominator, I need the absolute value of u. I don't need the bars, but I can talk about that later. Because e to the 2x is always positive, but I'll write it in there first. And then I'm going to have u squared. So when you square something that already has a power, when you square e to the 2x, you multiply. So this is going to be e to the 4x. So it's e to the 2x times the power by 2, which is e to the 4x, and then minus 1. So that's what I'm going to get there. And the thing that you notice here is these cancel. You really don't need these bars here because e to the 2x is positive all the time. So the bars really aren't necessary. And then those cancel. So the answer is 2 divided by the square root of e to the 4x minus 1. Now, and again, the way I got e to the 4x is because you have to square our u. And when you take e to the 2x and you square it, when you raise a power to a power, you multiply. So that's how you get e to the 4x when we square this u value right here. All right? And so that's our answer. After these guys cancel, we're left with 2 divided by the square root of e to the 4x minus 1. All right? So that was all of our differentiation ones. All right? And I think I'm going to split this up into 2 separate videos. So that's all your differentiation, and I'm going to make a separate video for the integration so that we're not getting long videos.